In this video, we write a C program to print n to 1 numbers using recursion. That means we want to print numbers from 1 to a given number in the reverse order. Now see this output. Let us say we have given number 20. Then we want to print numbers from 20 to 1. In the previous video, we have seen about a program to print numbers from 1 to n. But in this video, we want to print numbers in reverse order from n to 1. Now see this example. Here is the program. There is a main function, and main function is reading a number, a given number, and it is calling display function by passing n value. Now n value is passed here, and then display function is called. In the display function, it is having one base condition. If n is greater than 0, then it is printing n value, and also it is calling the same display function, and this is a recursive function call. This is a recursive function called display of n minus 1. Now we see what would be the output. This is the actual output. Let us say if we give number 20, then we will get 20 to 1. Let us say if we give 100, then we will get output 100 to 1. Now we see how this particular recursive function is executed and how the function calls are made, etc. Now this is the main function. Enter a number, okay, and then it is calling display of n. Now let us say we have given number 3 here, n value is 3. That means here also n value becomes 3. Now display of n means display function is called by passing value 3. Now in this display function, n value becomes 3. So a copy of display function is created with n value 3. Now what is the condition here? Here n value is 3. 3 greater than 0, that is correct. And then we are printing. What is the first statement here? Printf %d n. Then what will be the output here? What would be the output we get? We get n value. What is n value here? In the printing statement, n value is 3. We get output 3. And then we are calling display function, display of n minus 1. N minus 1 means 3 minus 1, that is 2. We are calling display function with argument 2. Now another copy of display function is created. Now this function is called, and here n value becomes 2. Why? Because 2 is passed here, display of n minus 1, that is display of 3 minus 1, 2. In this function also, n value is 2. Again 2 is greater than 0. Then we are printing n value, that is 2 value. Now what would be the output here? 2. And then this display function is also calling another display function, display of n minus 1. What is n minus 1 here? Display of 2 minus 1, that is 1. That is another display function is calling. Another display function is called with argument 1. Now here in this display function, n value becomes 1. Here condition, if n is greater than 0, that is 1 is greater than 0. Again the condition is true. Then we will print n value, that is printf %d n. Now n value is 1. We are printing value 1. And then it is calling another display function with argument n minus 1, that is 1 minus 1, 0. Now another display function is called with argument 0. That means here n value becomes 0 in this particular copy. N value becomes 0. Now here n value is 0. Now what is the condition here? N is greater than 0. 0 is greater than 0. That is a false condition. That means now this statement, now this condition is false. That means now these entire statements are not executed. That means now this base condition is used for exiting from the it is used to exit from the recursion. That means at this point of time there will be no more function calls. In this display function copy, we are stopping the recursion process. Why? Because n value is not greater than 0, n value becomes 0. That means there will be no more function calls. Now what happens here? When this function is completed, as there are no statements after if block, the control comes to the caller. Who is the caller here? This one is the caller. It will come here. Again there are no more statements in this particular case, that is in display of 1. Again the control comes to who is the caller of display of 1? Display of 2 is the caller. It will come to display of 2. Again there are no more statements after this if condition. Again the control comes to display of 3. Again there are no more statements in display of 3, and once this function is completed, then the control goes to the main function. Again there are no more statements in the main function. So in this fashion the recursive functions are called. This is the logic in this particular program. Now we see how the stack is involved in performing all these recursive calls. Now initially this is the code actually. Whenever the program is started here, the first function that is called is main function, and the main function will occupy memory in the stack, and in the main function we have declared n variable. N variable is created with value 5, and main function is calling display function with value 5. Now immediately a copy of the display function is created and it will be placed in the stack. Here a new variable n is created with value 5, and then what are the statements here? First of all, condition. Here n value is greater than 0, 5 is greater than 0. That means we enter into if block. In the if block we are printing n value, that is 5. Then what is the output we get here? What is the output we get? We get output 5, and then it is calling another display function with value n minus 1, that is 4. Now immediately another display function is called with value 4. Here a new variable n is created with value 4, then 4 value is printed, that is in the output we get 4, and then it is calling as n value 4 is greater than 0, it is calling display of 3, display of n minus 1, that is display of 4 minus 1, 3. Now another display function copy is created and it will be placed in the stack. A new variable n is created with value 3, and then 3 is greater than 0, then 3 value is printed, we get output 5, 4, 3, and again it is calling display of 3 minus 1, that is display of 2. Then a new copy of display function is created with value 2. Here a new variable n is created with value 2. Then since 2 is greater than 0, again we print n value, that is 2 value. Then it is calling display function with argument n minus 1, 2 minus 1, that is 1. Again a new display function is created, a new copy of display function is created with value 1. Here n value is again 1. As n value is greater than 0, then we print n value, that is 1, and then it is calling display function with n minus 1, that is 1 minus 1, 0. Then a new copy of display function is created with value 0. A new variable n is created with value 0. Here n is greater than 0, the condition, it will become false. Why? Because 0 cannot be greater than 0. At this point of time we are stopping the recursion process. At this point of time there will be no recursive calls, and once this function is completed, then automatically the control returns to its caller. Who is caller of display of 0? Display of 1 is the caller. Then automatically display of 0, it will be removed from the stack and the control returns to display of 1. As there are no more statements in display of 1, now observe here, there are no more statements in display of 1 to be executed, then automatically the control returns to its caller. Who is the caller of display of 1? Display of 2 is the caller. That means now all the variables related to display of 1, they are removed from the stack and the control returns to display of 2. Similarly, once the display of 2 function is completed, the control returns to display of 3, and the display of 2 function, it is removed from the stack. And once display of 3 function is completed, then it will be removed from the stack and the control returns to display of 4 function. And similarly, likewise, as there are no more statements in display of 4, it will be removed from the stack and the control returns to display of 5. Once the display of 5 function is completed, it will be removed from the stack and the control returns to its caller. Then who is the caller of display of 5? Main function is the caller. As there are no more statements in main function to be executed, then main function will be terminated and it will be removed from the stack. In this fashion, whenever a function is called, it will occupy memory in the stack, and whenever a function execution is completed, it will be terminated from the stack. In this fashion, we got output n to 1 numbers.